Hi, welcome everyone. This is the hopefully this is the last video in the series that we've been building this Asteroids copy game. Hopefully, if you've been following the video series up to now, you'll have something that should resemble something like this. I think we've had about three or four videos now, and we have our asteroids. We have our ship. Our ship moves around. It follows the point of the mouse no matter where it is, so we can use the mouse as a directional, and we can fire. And also the asteroids move off the edge of the screen onto the other side, as do the bullets, but the ship doesn't. So that's something we need to address, and there's a few other things we need to look at as well to get this to us. It's not going to be a perfect replica of the original game, but I want to get it close enough just to cover the key concepts and so that we have a working game. So let's just summarise the things I'd hope to cover in this video. If not this video, we may have to go into another one, but what I'm hoping to cover is, so we need to put the ship, needs to be able to go off the edge and then come on the other edge like the shots and the asteroids do, so that should be fairly straightforward. I also possibly want to revert back to the original movement control that I said I didn't want to do, but actually I might do, because at the minute we're using one that is probably more familiar with multiplayer games where you use the arrow keys to move around. But in reality, the asteroid game that you will have played originally has this, like, you move left and right to rotate the ship. So you press your left arrow and your right arrow, and then you press your up arrow to give you thrust in the direction that you're pointing. So a little different, but the more original movement. So I might leave that to the end and possibly do that at the end if we have time. But I'd like to. But it's not critical because I'm probably never going to use that in any other situation. So just to recap then, we have our asteroids, which were created using a bit of random noise as we plotted 10 points around each of the points of the circle, which is the blue bit of the asteroid. And then each point, the radius basically went either, it was a random point so much before the radius or so much after. So that, for example, this one here, that's the center of the asteroid. And this point here was more than the radius by an amount, but this point here was less than the radius by this amount. And then you just join the dots with the function that P5 gives you, and you end up with the asteroid. So that actually worked out quite straightforward, and we have all these nice random asteroid shapes. So let's see if we get the other critical thing we need to do is that when a shot hits an asteroid, and I'll try to remember to use my zoom feature this time. You see nothing's happening at the minute. Well, obviously that's no good. The whole point is that when a shot hits an asteroid splits into two smaller ones, and then each one of them, when they get hit, split into two smaller ones again, and then when they get hit, they disappear from the screen. And each time, each shot clocks up points on the scoreboard, so we need to somehow clock the score. And also the asteroids, as they get smaller, they get faster, so it's a little bit more haphazard on the screen. And then eventually all the asteroids clear, and you start again with a new screen. Now, I don't know how much of that part of the gameplay we're going to do, but at least if we can get the asteroids being destroyed and then smaller ones being created until eventually they're gone, I think I'll be happy if I can get that far. But let's see how far we can get. We're doing quite well, but I'm just really eager to get onto the massively multiplayer version of this. Okay, so I've got a few other things on my other screen here that's just going to help me to make reference to things in case I get stuck. That said, let's get started here. So I think let's just do some quick jobs. Let's make it so that the ship can go off the edge and then come on the other side. Do you know what? I'm actually not that happy with the dimensions of the ship either. It looks a bit weird. We'll come back to that in a minute, because I'm thinking about how this is going to work with the collision with the asteroid as well. We'll come back to that in a minute. We'll do the edges thing with the ship. So you remember we did this with the bullets and the shots, the asteroids, where we had this thing called edge. And with the shot, we didn't take into account the radius of the shot because it doesn't have one. It is just literally a point on the screen. But our ship has a radius in effect. If you remember, we built it based on a point from a center point that effectively we call it a radius. I'll tell you what we'll do. We'll just draw a circle around the ship at its radius and see how that looks. You know, the way we've done with the asteroid. So was it so that drew the yeah, so just this here, let's just copy this shape here, or this bit of code here, and let's just see what happens if I do that. Yeah, there we go. Okay, so you notice how we've got a circle around our ship, and it just gives us an idea as to where it is in relation to collisions and things, and also as it goes off the edge, how it appears, you know, at what point we determine it comes back on. So I think what we'll do, I think it's going to be a safe bet to maybe do it as the same as the asteroid, where the asteroid has to go off. So I think we'll do it the same way, where it has to go off by, did we do it as it's half its radius or its radius? Where's the edge function? So we added its radius, that's right, yeah. So what we said was, when the middle of the asteroid gets to the edge, but then you have to add in the radius so that it completely disappears off the screen. So round about now, there, and then that should then start appearing on this side. So we can do the same with the ship. So on that basis, we can just copy the asteroid one, the asteroid edge function. Let's copy that, and we'll move that into the ship. Okay, and then I think we have to call that in the main code as well. So where I've forgotten where that is that in the app? Oh, original. So that's components original, that's right. Yeah. Okay. So in here, somewhere in the draw method, where we draw the ship, here. So you notice how for each asteroid we do the edge and then we show it. For each shot we do the edge and then we show it. And we want to do the same with the ship as well. We want to show it. So we want to do the edge and then show it. So the edge, if we can copy that line. If you're using VS Code, what I use is, I don't know if this is the default key command, but I used Shift and Alt and then down arrow. And then that gives me a duplicate command. I don't know if that's the default for VS Code, so maybe it might be something like Command D or something. I don't know. There's a few different options for that. But either way, just copy that line. You can copy and paste it if you want. And just do this ship edge. And then if you remember, we pass in this client because that gives the whole width of the plane area that's the ship's plane in. So it knows how far it needs to go before it crosses over to the side. So that now should give us the ship. Now remember, when we're using P5, I like to just reload the page anyway. So let's see if this works. Let's go off the top. Hey, there we go. It comes back up on the bottom. Let's try the other way. There we go. Comes off. That's excellent. So yeah, all working great. Okay, so let's think about the I've lost. Is that not shooting anymore? Oh, I appear to have lost the shots. What's happened there? Okay, so what I've just done is in the rules section, I've found this on this page, no console off, so hopefully that'll allow me to do consoles. So I've added that within the rules section in the package.json. And what I'm going to run now is npm I, and hopefully that will reinstall the packages, including this new rule, which means I can do console logs, and then hopefully this will work. I can't remember what we did in previous videos. I'm sure we were able to console log out. So hopefully now this should work without any errors. Okay, yeah, so we appear to have an error, but we are still showing. No? Okay. What I'm going to do is just open up the inspector here. So let's reload the page in that window. Okay. So yeah, okay, no errors, that's fine. So hopefully now, when I fire a shot, the idea was that it should show me something. Yeah, so the shots are definitely there. You can see as I add. Now obviously the number only goes so far because as the shots go so far they disappear. So it looks like the shots are being created, they're moving and then they're disappearing, but they're just not showing on the screen. So I've obviously interfered with how they're shown on the screen. So let's have a look at the shot class and then show. Maybe we just need to put a bit more specific parameters in here. So let's see what we did with the ship, for example. So we set stroke weight. Well, there's no stroke because it's a point. So we probably need to set the stroke color, which is this. So let's try that. There we go. So that's what it was. So it looks like whatever I did must have changed the colour. When I did this circle here around the ship, it must have interfered with then the shot colour, and the shot just wasn't being shown. It was there, but it wasn't being shown. So that's okay. Okay, so we can get rid of that console log now as well. Wherever that was there. So we don't need to see the shots anymore. Excellent. So, okay, so we need to think about collision now then, I think is the next thing. So let's think about this for a second. We have an asteroid, we have a shot which we want to collide with an asteroid, because as soon as the shot hits the asteroid, that would be deemed a collision and trigger the process of splitting the asteroid or destroying it. And also, if an asteroid hits the ship, then the ship loses, as a player, you lose a life. So that's a collision as well. The shot and a ship is not really a collision. I don't think, in the single player version of the game, I don't think you can shoot yourself with your own bullets because they come back around. I might be mistaken, but I'm pretty sure you can't shoot yourself. So, well, that's not a collision. So on that basis then, let's think of it, let's turn that around slightly. We can have an asteroid can collide with the ship, and an asteroid can collide with a shot. So that's basically the same as what we've said, but from the asteroid's point of view. So if that's the case, for this single player version of the game, what we could do is put all the collision logic in the asteroid class, because it's the asteroid that's going to determine. If we can put it all in there, then we only have to keep one set of checking rather than check the shot for what that hits and then check each asteroid for what that hits. We might as well just put it all in the asteroid class. That might not work so well in the multiplayer game, because of multiple players with different shots for different ships, but certainly for this one I think it'll be fine. So basically all of this collision detection is going to go in the asteroid class. Now this is where I was thinking about why the circle is important here, because if trying to determine how it collides with a triangle, I'm not quite sure how that's going to work. Now I did some research on this, and there is a library for P5 called P5 Collide 2D. Ooh, it's been a dinosaur game. I appear to have lost the internet. Yeah, this is great. This is what you're watching on YouTube right now. Yeah. Okay, well, it was weird. It's fun while it lasted. Anyway, so this is P5 Collide 2D. So this is something that's been written to work with P5 for the purposes of collision. Now, there are some dedicated physics libraries out for JavaScript out there. There's one I'd like to look at some point in the future called matter.js, which looks really cool, and Dan Schiffman on his Code and Train channel does use it once or twice in some of the projects he does. So we might come to that in some future time, maybe as part of this game or maybe another game we do, and that deals a lot more with the physics side of things, to do with actual inertia, gravity, momentum, all that kind of stuff. This, all we want here is a simple collision detection, but we want it on a triangle shape. See, if we were doing it with just two circles, and this is where I was thinking maybe just get away with the circle collision. Let me just draw this out why I thought I might get away with this one. There we are. So, I got this on the screen here. Yeah, okay. So I've just got my iPad here. So what I was thinking was, if we've got a circle here, let's do two instances here. So let's say we've got the circle of the asteroid and we've got the circle of the ship. Now it's quite clear to us visually that they haven't collided yet. So, but we need to work this out in a pragmatic way for the computer to work out that there's no collision. So the other scenario is that there is a collision. So let's draw an asteroid and then let's draw the circle of the ship. Now obviously remember that we're talking about, that was meant to be a triangle. Okay. So we're talking about the, oh that's terrible. So we're talking about the ship, and you can see the problem probably already here is that if this let's tell you what, let me just undo that. If let's say that was the triangle, so you can see that the circle that we've been working with here, this outer circle, can obviously touch the asteroid before the actual ship itself, and that's an easy way to determine a collision, because the way you determine a collision on two circles is you get the radius of this one, so that would be R1, and then you get the radius of this one, that would be R2, and if the distance between the center point of the asteroid here and the center point of the ship here, if that distance between them 2 points is greater than R1 plus R2, then the circle can't be touching, it can't be overlapping, because from here to here is R2, from here to here is R1, and there's this distance here. If on the other hand, that's R2 and that's R1, now you can see that the distance from here to here is going to be less than R1 plus R2. So that, in that instance, pragmatically, we can say that that is a collision. If the distance between the two origin points, the two centers, sorry, of the two objects we're dealing with is less than the two radii added up, then it's a collision. If it's greater, then it's not a collision. Now that's the easy way to do it. If we were to treat the asteroid as a circle, which we're probably going to have to do, and if we were to treat the ship as a circle, which I don't know if that's great based on the amount of collision. I mean, you know, you're going to have a large amount of gap between the actual edge of the circle and the ship. You know, that would class as a collision. I suppose we could do that and just leave the circle in so that from the player's point of view, they know where the collision is, even though it's not actually hit the ship. That could be one option. The other option is this collide library, and you can see that it deals with most of the collisions dealt with like a point to something, a line to something, a circle to a polygon, a line, point to a polygon, a line to a polygon to a polygon, a point to a triangle, and I think this is the one we were looking at, a 2D primitive to a triangle, because I think a 2D primitive would be like a circle, which is what we've got with the asteroid. So that's the other way to do it, is that perhaps maybe, actually we have a circle polygon here. Oh no, that's triangle. So yeah, we could use this library. I'm not overly familiar with it. So what I'm going to do for this single player one, I'm just going to do the idea of the circles like this and leave the circle in of the ship. In fact, what we can do is actually just change the color of the ship's color of the ship's circle. So if we say, let's say that's the red channel, the green channel, and the blue channel. and the opacity, which is how solid the line is. So let's save that. Let's see what that looks like color-wise. Oh, okay, yeah, okay. So we have a red circle. I'm just going to reload that page because everything's slowed down. My iPad back there, so there we go. So we now have a red circle. So what we're going to do, I think, is we're going to do a collision where we go there. So that's a collision. Even though the white isn't touching the white, the red is overlapping with the blue. And we're going to treat that as a collision for the purposes of this game. It's not highly accurate, but it'll show the purposes of what we're doing here. So, and then we have the collision with an asteroid with a point, obviously. We're just going to use the circle again as a reference for that. So what we need to do is go into our asteroid class, and we'll create a new function called collide. And no. Let's see, how can we do this? Yeah, let's call collide is going to be the function for if the asteroid hits the ship, and then we'll have another function called hit, and that will be the function for if the asteroid is hit by a shot. So that covers both angles, doesn't it? So let's think about the collide option then, first of all. Okay, so what's going to happen is every time we run through the draw function here, you know, remember this loops. So we go through each asteroid here. So we have access to each asteroid. So what we can do here is we can actually check now if the asteroid has collided with our ship. If this particular asteroid has collided with our ship. I've sort of done this the wrong way round. This would work, but it's going to be highly inefficient, because in reality, at any one time, only one asteroid is going to hit our ship. Yeah, every time I'm going through the draw loop, we're going to check every asteroid. Now, granted, we only start off with 10, and if they split down to like multiple times, the actual maximum asteroids in the game is going to be 40. 10 becomes 20 and 20 becomes 40. That said, it's pointless doing this if it's not the best way to do it now. So with regards to collision on the ship, or if we do it on the ship, no, because we still need to loop through each asteroid from the ship to check if the ship's hit any given asteroid. So no, actually this is probably just as good this way. Sorry, just a bit of a brain meltdown there. So let's call this dot asteroids x dot collide. So remember, this is, we're checking if we have hit the ship. So we really could do with passing in the ship's position here, because ordinarily the asteroid wouldn't know anything about the ship. So we've passed in ship position, defined but never used, that's fine. So ship position now contains an X and a Y. Remember that the position of the ship is a vector. Remember, this position for the ship is a vector. Okay, so we have our ship position. So remember, the equation effectively is, we have our ship position, which is the center here, and obviously we're inside our asteroid class now, so we know here. So we need to work out the distance between this two. Now, if you know your geometry, you'll know that the Pythagoras theorem is what comes into play here. So let me just simply illustrate this here. So we have a y-axis and an x-axis. Yeah, looks not unlike a y. Where is that? Okay, I'm doing it with my finger. I can't find my pen, so not the greatest. So if, say for example, we had a point here at 1, 1, okay, and we have a point here at, say, I don't know, 3, 4. So that's 3 on the x-axis, 4 on the y. So you remember from Pythagoras that if we had a triangle, if we have a right angle triangle, that the sum of the hypotenuse, no, let me get this right now. The sum of the square, the square root of the hypotenuse is equal to the sum of the square I can't remember the formula. The square of the hypotenuse is equal to the sum of the squares of the two adjacent sides. Yeah. For the life of me, I couldn't remember. So what that means is this square is equal to this, in area, is equal to this square plus this square. So how does that help us with the position? Well, if we know this distance, because it's going to be the x of the ship centre, or the asteroid centre, minus the x of the ship centre. We know this distance, because it's the same with the y's, the centres of the asteroid y, the centre y position of the asteroid to the ship centre y. So that gives us this distance. If we square them two distances, so that we get a squared value, and we square this one, and we add these two areas together, then do a square root, because these two areas added together will equal this area here. So if we square root this, we end up with this distance here, and this distance is what we're trying to work out, the distance between the centre of this point and the centre of this point. So that's why Pythagoras theorem is what we need to use here. So let's have a look here at what we have. So we have our asteroid position, which is going to be this dot position, and we have our ship position, which is what we've passed in this ship position. So let's break this all down into simple steps. We could do it a lot more concise on 1 or 2 lines, but let's just break it down into steps. Okay, so let's do this in steps. Let's first of all get the x position and the y position here. So we are on Collide, aren't we? So let x, yeah, just call it x. No, I don't like the idea of x length equals, so we want to do this dot position dot x minus ship position dot x, and then let y length equals this dot position dot y minus ship position dot y. Okay, so we now have this and this. So for both of them, we need to square them to get these values here. So let x squared equals x length multiplied by x length. Let y squared equals y length multiplied by y length. Okay, so we now have this value and this value, so now we need to add them together to get this value. So we'll call it h squared. Let h squared, so that equals x squared plus y squared. So yeah. Yeah, I think so. Mum brought them in. Take one. So this was x squared, this is y squared, and we'll call this h for hypotenuse squared. And we've added these two together to get this. So now to get this distance here, we need to get the square root of this value. So we should be able to say let h equals how do you do square root in JavaScript? SQRT, is it? See if that causes an error. SQRT is not defined. I've got a suspicion that P5 has a square root method, but we're probably going to have to import it, bring the P5 library in order to do it. Let's just see if it's SQRT. Yeah, thought there was. So oh, that's cool. So yeah, so this is the square root SQRT, which means it's P5.SQRT, which means we need to bring P5 into this method. So we'll put a placeholder for it there, and then if we go to original, remember all we have to do is pass it in as the first parameter there. You could put it as the second parameter. In fact, if you were adding onto somebody else's code or an existing code base, you may just add it as another parameter at the end, but because we're writing this from scratch, I just like to put the P5 bit at the beginning and then everything else after that. But just make sure that whatever order you put them, when you call in the method here, that they are in the same order. They are in the same order when you actually define the method here. So P5 is first, ship position second. Okay, so it's saying P5 is not being used, which is fine, because now all we have to do is prefix that SQRT with P5, and that should solve both our problems, except it doesn't because we haven't done anything with H. Okay, so H now is the distance. So remember we said that's the distance between the two center points, and what we're checking is if that is greater than or less than the two radii added together. So let's get the two radii. So well, we already have them, don't we? We have radius on asteroid and we have radius on ship, so we already have them. So all we have to do now is now again we could do this all in one line. I'm just going to be very verbose and write it out explicitly so you can see what's happening here. So I'm just going to call this let radii equals this dot radius plus ship. Ship position is not what has the radii in. So what we'll do is we'll pass in a third parameter called ship radius, and so the radii is the asteroid radius plus the ship radius, but we have to pass this in now into this method, this collab method. So let's go back to original. So we have P5, the ship position, and now we need the ship radius. There we go. So we now have our combined radii, and we want basically what we're saying is if the combined radii, so let's say that's 2 and that's 1, So that'd be 3. If 3 is less than the distance that we've just got from this here, the h length. So if the combined radii is less than h, then it's not a collision. But if it's greater than h, it is a collision. All right, let's see if that works. So if radii is less than h, else. So let me just get this right now. If the combined radii 3 is less than h, which say could be 4, then it's not a collision. So this is not a collision. So we don't really need to do anything here. So rather than having an else, which is a collision, what we can do, let's get rid of all this together, and we can just swap this round. So if the radii is greater than h, we only want to check if it's a collision. It's a collision if the two radii added together is greater than the distance from the centers. That's right. So this is now a collision. A collision has occurred. So what we're going to do is we're just going to say console.log, and we'll just output some text to the log and just see whether that actually shows. So let's try that. Let's reload the page. Now check the log over here on the right. Let's get out the way first of all. Okay, so check the log down here, and hopefully when we run into a asteroid, yay, look at that, collided, and then it stops. Now, because the message is the same every time, rather than output it 145 times, it's just said the last 145 are the same message, which is collided. But definitely, let's put it in the way this one. There we go, and it ramps up again even more. I'll just actually use my zoom feature, which I've been threatening to use. So let's get in the way this one here. And there we go. You can see that number ramping up as it's going through. As soon as it comes out, it stops. So that is perfect. We now know when the ship is colliding with an asteroid. We only have to know at the point it does it though, because as soon as it does it, that's game over for the ship. And we'll have to sort of put some kind of function in for that. What we'll do for now is just simply say p5 dot no loop, which is a method that stops the drawing process. So let's see if that works. No loop is not a function. Is it no capital L, is it? Okay, so as soon as we hit, oh, that was close. Let's just go and hit this one here. There. So it just stops the drawing process and freezes the game. So I might leave it at that for the game end process, because I'm not really fussed for developing this right to the very end. But you see what's happened. A collision's occurred, the game stopped, and we can put in some extra features to cater for, like, you know, if you've got another ship left, use your next ship and stuff. But I'm not really fussed for that right now. So that's good. That's the collision for the asteroid. But now we need the collision for the ship and the shot and the asteroids. So how can we do that? Okay. So we have our hit method now. So for every asteroid, we're going to check if it's been hit by a shot. So that means we could do a passing in here the array of shots that we have in the main game loop here. So this dot shots. So what we can do is take this dot shots, we'll copy that, and we have a collide. What we're going to do now is do this dot asteroids x dot hit, and the first parameter we're going to pass, I've got a suspicion we're going to be using p5 again, so I'm going to put p5 as the first parameter, and then I'm going to pass in the array of shots, which are the current shots on the screen in play at any given time. So we'll pass that in because we need to loop through these for each asteroid. So let's do that. how did we loop it in the other one? So for, oh yeah, so we just did a simple for loop. So for s equals naught, while s is less than shots dot length s plus plus. Okay, so now remember that we're inside each asteroid when we call this method. So every asteroid is going to have this hit method called, and so every asteroid is going to have to loop over each shot to see if it's been hit. So it's like an exponential. It's the number of shots multiplied by the number of asteroids. So you can imagine how on a huge game this could be quite intensive, and there's ways we're going to try and optimize that as and when we get to that point. But for now we're just going to do the brute force method of going through all the asteroids, and for every asteroid check every shot and see if there's any collision between the two. Okay, so let's do a similar thing as we did for the collide thing method here. So let's copy this, all of this code, and just paste it in here. And so this position, that's fine, but we're not doing ship position anymore. We're doing the shot position. So I can take ship position and we can say shots s, because we're looping through the shots.length. We can grab the s element, which is where we are, and the same for here, shots s. Okay, so ship radius is not defined. So you remember the shots don't have a radius. So this is a little bit different now. Let me bring this up. And I'm running out of space. But this is a little bit different now with the shot, because rather than checking to radius, you're simply checking there. So on the top one, you're simply checking if that dot is on or inside the asteroid circle, which it isn't, and on the bottom one it is. Now how do we check that? Well, we don't have to measure a radius of this, we simply check its point, its center. So we say, remember this Pythagoras theorem here? So we have an x value and a y value, and that gives us this value, and all we have to check then if it's this value greater or less than to the radius of the asteroid. We don't have to work out the radius of the point, because there isn't one. It's just simply the point where it is. And it's the same with here. We have an x value, a y value, and if the corresponding h value, our hypotenuse, is less than the radius, which it is, then that deemed as a collision. Obviously, as soon as it hits the edge, it'll deem it as a collision, but we'll just check whether it's gone over it in case there's a glitch in the code and it doesn't catch it at the first point. And if it doesn't catch it at the first point, we don't check it for if it's any further points, it could effectively just go straight through the asteroid and not mark as a collision. So we're just going to check if it's beyond that boundary regardless. So how do we need to change that here? Okay, so the x length is the asteroid's x position minus the shots, simply the shots position x, and the same with the y. Okay, so we get the x squared, the y squared, the hypotenuse squared. That gives us the hypotenuse. So then we don't need to check we don't have ship radius. So the radius now is basically just, there isn't a multiple radius, it's just the asteroid radius. So we can say this dot radius, and again we'll just stop it with a loop for the time being. So let's save that. So P5 is not, oh yeah, of course I didn't pass in the P5. Well, I did, but I didn't account for it here. So P5, S is not defined. Oh, I need to do let S. Okay. So let's see how that looks. Ooh, graphic. Okay, so we know our ship collides. I'm not going to collide because it does a no loop. But if I shoot that, and there you go. So that's actually a really good freeze frame. The first available frame where the dot was deemed to be, now think about it, this is what I was just saying, if it was only doing it if it hit the edge, the next available frame, the dot's actually worked out to be here, it's past the edge, it wouldn't have classed as a collision and it would have just carried on. So we just need to check if it's anywhere near beyond the point of the circle towards the radius, the center of the circle, to deem as a collision. It has, and it's at that point there, and the loop stopped. So that's brilliant. We've got our collision detection in place. So when the ship gets hit by an asteroid, we just entered the game, but when the asteroid gets hit, we need to do something with this. And you'll remember on the original game that the asteroid breaks up, the first asteroid breaks up into two smaller ones, and then the two smaller ones break up into two smaller ones each, so that you have four asteroids floating about, and then each one of them, when you shoot them, they just come off the screen, and that's it. That's the end of the life of the asteroid. So we need to sort of have a status to say at what point this asteroid is. Is it a large asteroid? Is it the medium asteroid? Or is it the small one? So let's go back to the asteroid class, and we'll say, let's just put in a new parameter called, let's call it stage. And what we'll do is we'll give it a number, and then every time when we set up a new asteroid that's the next one along, we'll increase the stage, and we can just simply check the number value then rather than the name of it, because we can just add to the stage when it creates the new one. Come back to that in a second. So stage equals 1. So if it's hit, now, so this is the point where we determine it's hit. So here, what we need to do is effectively, let me just comment what we need to do. We need to remove this asteroid, because this asteroid's been destroyed, but then we need to create 2 new asteroids smaller asteroids, or nothing. Now I say or nothing because if it's the smallest asteroid and we destroy it, it just goes and that's it. So we need to work that one out as well. But we need to remove this asteroid. But before we do, do you know what? We need the details of this asteroid to make the 2 new ones, because we need to know that the 2 new ones start where the old one dies. So it might be worth creating the 2 new ones first. So let's move that up here. So we could do it checking now the stage of the asteroid. So if this dot stage is less than 3, so if it's 1 or 2, we can create 2 new ones. And now all we have to do is create 2 new asteroids. Now we're inside the asteroid class, so creating a new asteroid inside the asteroid class, is that a good idea? Right, what I'm going to do, let's just copy this out. I'm going to do it as a returnable value. So what this says is we're going to run the hit, we're going to loop through each of the shots, and at any point if a shot has collided with this asteroid, we're just simply going to stop the loop and return true back to the calling code in here. Otherwise, if it loops through all the shots and nothing's hit, then it'll return false. Okay, so let's go back to the calling code. So the calling code here is hit. So you remember last time we used a function and we returned a value off the function, and we were sort of saying this is an important part. I can't remember where we did that. Was it this frames? Anyway, it doesn't really matter. So we're going to do the same again here. So with our hit, we're going to say let is hit equals the result of that method, and remember that method is either going to be true or false. So this is hit is now going to equal true or false. We're going to do it back in the original code so that we don't have to do it in the asteroid class. The asteroid class manages each individual asteroid that we create. Creating new asteroids is not really the job of an asteroid. It's the main calling code, this original file that we have here that we're going to use to do that. But we need to know the asteroid tells us by this method if it's collided with a shot. So we need to know that here. And this is hit variable tells us if that's happened. So now what we can say is if, and if it's a true or false variable, we just need to check if, because remember inside an if statement here, the evaluation has to be a true or a false. And because this is a true or a false, this is hit, then we just say if that, which basically means if it's true, run the code inside these braces here. So I hope that makes sense. If we have a collision with a shot, it's going to return true to the hit method. So this hit method will return true, which we assign to this value, and we run this code. If it's false, it'll assign false to this value. It won't run this code. So now in this code, we can say create the 2 asteroids and delete this one. So let's do that. We have there we go. So we create an asteroid by using we put it onto the end of the asteroids array. So we remember we pushed it on. Now we now need to think about this because we now need to set we default stage equals 1, but what if it's not? What if it's now one of the smaller asteroids? We need to tell it that. So let's put in a stage thing into the constructor, a stage parameter, and then we can just say this dot stage equals stage. Let's just make that blank. So when we set up the screen for the first time, these are all going to be 1. So new asteroid P5, width, height. Was that the radius? Width, height, radius, and stage. Okay. So width, height, radius, and stage. So we know that's a 1. But here, it's not a 1. It's going to be a 2 or a 3, depending on what the value of the asteroid currently is. We're going to add 1 to it. So here we can say this dot asteroids x dot stage plus plus. I think we've dealt with the plus plus parameter before, haven't we? It just increments by 1, just adds 1 to the value. So now when it creates this asteroid here, if the original asteroid was 1, this one's now going to be 2. And remember, we need to do this twice. So let's copy that line twice. And then we need to delete the original asteroid. So remember, we use the splice method. I think we discussed this in the previous one of the previous videos. So we can say this dot asteroids dot splice, and we are at x, and we only ever delete the 1. So we push the 2 new asteroids on, we delete the current asteroid, and then we carry on as normal. That should work. I'm just thinking that the stage is going to determine. Yeah, I've done this a little bit wrong in that. Let's make them 30 for this one. We could get the asteroid to set these things up depending on the stage, but I'll manually put them in now because we need to set a velocity for the asteroids as they get faster and faster as well. Let's just try this for now. Let's see if this works. Okay. So let's try and hit 1. Hey, something happened there. Oh. So it's definitely creating a new asteroid, or two new asteroids. Whoa, whoa, whoa. Okay, I got a bit wild. But it's not creating them. First of all, it's not creating them where the old asteroid was. So we don't want to set it to a random point. We actually want to set it to the X position of the current asteroid. So we can say this dot asteroids to X dot position dot X, and then this one, instead of doing a random height, we can say this dot asteroids X dot position dot Y. Okay, let's see what that does. So let's reload the page, and if I shoot, whoa, 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 what happened there? Wow. Okay. Now, I've just realised, remember we said when we delete anything from the array we have to go backwards, and we haven't done this here, so let's just do that. I'm not sure if that's going to fix the problem here. I hope it does. So while x is greater than 0, and then we do x minus minus. Let's see if that works. That looked a bit weird. Okay, so let's shoot. Oh. So what's meant to happen also is the shot. See, the shot just carries straight on through and just goes bang, 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 bang through all the rest of the asteroids. Obviously, we need to remove the shot as well. So let's do that. So if it's hit, where are we? I've forgotten what we're doing now. Let's have a think. We're checking the hit. If it's hit, okay. Okay, we're going to have to change this slightly, but it doesn't matter. This is all part of coding. So at the minute, we had this method simply returning a true or a false. So where are we? Here. So we return true if there was a hit with a shot, or we return false. However, this works, but what it doesn't tell the calling code is which shot it was that it had a collision with, because it just simply says a shot had a collision with you. So the problem with that is, because we need to remove that particular shot from the screen, this code isn't now that good enough for that. It just tells us that there was a collision, but we need to know which shot it was that it collided with. So what I'm going to do, I'm simply going to leave this as false, but rather than return true, I'm going to return the index of the shot that it collided on, and all I have to do for that is return s, because s is the current index of the shot that we're iterating through here in this for loop. Okay, so let's go back to original. So now, rather than is hit, now we can call, we could leave it the same name, but I don't want to leave it confused. So we can say shot index. So let's call it shot index, and then we can say if shot index does not equal false. In other words, if it's a shot number. Now this is important. I don't want to spend too long on this, but depending on there is actually a difference between that, which means doesn't equal, and that, which means doesn't equal. The difference is, and I might not be absolutely accurate here because it's something I'm still trying to get my head around, but this is a non-strict comparison, and in a non-strict comparison, the value 0, just a naught, equals false. I'm pretty sure that's what that case is. The problem we have with that is that in our shots array, there is a legitimate value called 0. So imagine if the first shot is the one that has a hit with a collision, or a hit with the asteroid. So we will be returning here 0 because it's index 0 in this shots array that's got a hit. That's a legitimate value to return. But if I left that as does not equal with one equals sign, and it came back as 0, that would then not register because 0 would equal false in that case. And we're saying if it doesn't equal false, or if it doesn't equal 0, we can do all these things. But that would have equaled 0, and we still should have done them things. So that isn't going to work. So then we have to put in what's a more strict operator. I'm so sure someone in the comments is going to correct me if I've got this wrong. But as I say, this side of things still a bit new too. But what this means is that we are strictly checking if it's a false or true. A Boolean is the term for whether it's a false or a true. If it's not a Boolean false, so in other words now, a 0 no longer counts as a false if we do it this way. It has to be an explicit true or false. If it's neither of them, then it's no longer considered a Boolean, which means even a 0 is not going to be treated as false. So now, even if it's a 0 or any other value that's not a Boolean false, it will run this code, and that's what we want. I hope that makes sense. Again, if anybody wants to make a comment about this in the video comments, just to clarify that, I'd be very grateful. But that's my understanding of it. So now we have shot index. So not only can we splice the asteroid off the array of asteroids, we can now say this dot shots dot splice, and we have shot index, and obviously we're only going to take one off. So now if I run that, let's just make sure I don't hit an asteroid. So I'm going to shoot this asteroid here and see what happens. Brilliant. Except it only created one. Did it create that one as well? Let's just shoot this one. Yeah, that one and that one was created. So one of them's created at the original asteroid position, but the other one isn't. The other one is just sort of randomly created somewhere else. Oh, yeah, because that's because I haven't copied the code across to it. So let's just copy this code. Anybody who did that before I did, brownie points to, yep. Okay. So let's just reload that page. Okay, so let's see if I can shoot this one. 2 asteroids. 2 asteroids. Yeah, excellent. Okay. So that's worked well. So the problem we've got now is this value is going to be determined on the stage. So rather than just say 30, I've made this a bit clunky really, but only because there's only 3 sizes, I'm going to live with it for now. So we're going to make this value based on the value of stage. So what we're going to do now is say remember, at this point we haven't done this increment yet, so this could still be 1. So if this dot asteroid stage equals 1, then it's going to equal 30, otherwise it's going to equal 10. So I'm just going to copy this across to here, and then let's explain what's happening here. This is called a ternary operator, and it's a shortcut. Let me write out the long version of this just to try and explain this out a bit more. So let's say if Let's just give myself some room here. Okay. Now this is not strictly the case because we're not returning here, but to just put 30. Well, I'll just do it like that. That's as close as I can get. So basically, what this code here. Let me just make this a bit wider. There we go. So this code here is basically saying this: if the incoming asteroid that's been destroyed is equal, the stage value is equal to 1, then we know it was an original asteroid of a radius of 50. So we know that it needs to go to stage 2, which we're going to call a radius of 30. The only other asteroid that can come in is a stage 2, which becomes a stage 3. So all we have to say then is, okay, if it's not a stage 1 coming in, it must be a stage 2 coming in. And if it's a stage 2, we can set that radius to 10. Now, the advantage of this, as you can see, is the whole of that logic can be put in this inline ternary operator here. And it's split up into 3 parts. So you've got the bit before the question mark, which is the evaluation. So just like inside an if statement here, this has to evaluate to true or false. If it's true, it goes whatever you want to be passed in here as if you typed it in is this, and then after the semicolon, if this was false, then what would be replaced here is that value if this evaluated to false. So basically this is saying we're either going to hard code a 30 in here if this bit evaluates to true. If it evaluates to false, we're going to hard code a 10 in here. One or the other. So that's all what this is saying here. Okay, so hopefully now, let's reload the page. Okay, cool. Let me just reload that page. Okay, so we have our asteroids. Let's shoot this one. Oh, so that's immediately gone to the smallest one. 1, 2. Okay, so that hasn't quite worked. Oh, of course, because it's stage 1 here, but then here it's stage 2. So then when it comes to this line, it's stage 2. So what we'll do, we'll set that let new stage equals let's get the current stage. Let new stage equals current stage plus plus. So now new stage, we don't have to plus it twice. We can just simply say new stage. And we can do the same here. New stage. But we can keep the original stage there, so that should work fine now. So let's just move out the way. Oh, it's gone slow again. Let me just reload that. Okay, so that's cool. Let's shoot this one. So it's gone immediately to the smallest one. Okay. Not doing any plus anywhere, are we? So new stage, so this asteroid stage equals 1. Oh, because I've added it and I'm still evaluating it after I've added it to that. So let's just do new stage plus plus. Okay, so we've left the original stage value intact. So let's just reload this page. Ooh. Right, so let's shoot this one. This one. That looks good. Let's shoot this one. and this one. Now, at that point, that asteroid should have just been destroyed, but because we haven't told it to, it just keeps creating 2 asteroids of the 10 size. So yeah, so that's good, but the rest of that logic's working great. So we just need to get rid of the shot or we need to get rid of the asteroids, or not create the new one, if the incoming stage is 3. So if new stage before we add 1 to it is 3, that's the last one, so there's pointless doing any of this, but we can remove the asteroids, so we're not going to add the new ones. So that means we need to wrap the if statement around these statements here. So if new stage equals 3, in other words, if it's the smallest asteroid we're prepared to build, then we're not going to build anymore. So, no, sorry, if it's less than 3, we want to build more. Otherwise we won't, and we'll just remove the current asteroid and the current shot. Let's see if that works. Instant collision. Ugh, it wasn't fast enough. Okay, so let's shoot this one here. So we have 2 there. Okay, let's shoot this one here. This one here. Okay. Shoot that again, it goes to the smallest ones. Shoot that again, and it disappears. Shoot that again, it goes to 2 smallest ones. Shoot that again, and it disappears altogether. Now, so that's errored on shooting a asteroid that it appears not existing in the array. So let's see where the error is. Undefined, draw. So at this asteroid's show, so that element, the asteroids of X, doesn't exist. Let's have a look at the, so that's this here, this. Oh, of course. If we're getting rid of the asteroid from the array, we shouldn't show it. So, where do we put this? We're getting rid of the asteroid here, which is inside this if statement. So we only show it if we're not going through this whole process. That's right. So we need to wrap that inside an else. So basically we're saying if a shot has collided with an asteroid, we create the 2 new asteroids, we delete the asteroid to delete the shot. Otherwise, if the shot was if it was false, in other words, there was no shots interfering with asteroids, then fine, we just show the asteroid as is. That's excellent. Let's see if that works. Obviously it should work. Well, let's just check for sure. Okay, so let's just hit this one here, hit him again, hit him again, hit him again. Okay, this is looking good. Hey, this is looking good. No errors so far, and everything seems to be working. Ooh. Okay, well, yeah, that seems to be working fine. The asteroids are losing their diameter, but what they're not getting is their speed, their velocity. So we need to just do that as well. So let's have a look. How do we set that? I think that's okay, so we're setting that as a random value. In reality, see, we could set the radius here as well rather than outside. We'll leave it outside for now, but we can set the velocity here based on the stage value. So this is going to be horrible from a coding point of view, but I'm just going to... do I want to do this? Yeah, I'm going to do this now. This is not good, okay? And in the multiplayer version, as I keep saying, we will address this, but I'm just going to make this a really hacky if statement for now, just to get this working. So if stage equals 1, in other words, if it's the biggest one, then we can say, actually we can set the radius here as well. This dot radius equals 50, and this, let me just pass the velocity, as well just put that in there, and that's going to equal a random vector, create vector. How can we set it to be of a minimum value? If it's P5, it's between 1 and 1 plus minus, so we can do it P5 create vector dot, and then we can multiply that by, well, we won't multiply that. However, we can say if stage equals 2, this dot radius equals 30, and we can then multiply this by 2, and then if it equals stage 3, oh, this is horrible. Please forgive me, all you JavaScript programmers out there. And then we'll multiply that by 4. This dot points equals 10. Why did I put? What is even that? Did I use points? Oh yeah, sorry. It's the yeah. So this needs to be proportion to the. This 20 needs to be proportion to this stage as well. So, okay. So we've got a radius and a velocity. Let's get rid of radius from the constructor, which also means we need to get rid of when it calls radius here. So we no longer need this ternary operator here. Man, I've taken you all around the houses today, haven't I? So where else did we create asteroids? There, so we don't need that. Okay. And so yeah, we could do with this 20 here needs to be, what can we call that? If we call it noise, let's just call it noise, and we can say let noise equals, I thought it was a bit, no, let's leave it at 20. Let noise equals 20, let noise equals 10, and let noise equals 5. So depending on which stage of the asteroid is at now, we can set 3 different parameters, and rather than having minus 20 and 20, we can simply say minus noise and noise. If this works, well, no, that was going to be too easy, wasn't it? So R is not defined. This dot radius equals R. Yeah, we don't need that anymore, do we? Because we're setting it dependent on the stage. So let's get rid of that. Error. Noise is assigned a value but never used. Let noise. Equals minus noise common NOISE. NOISE. Oh, yeah, I don't need to put let there because I've declared it up here. So that means it's this dot noise. So if you put this, I'll show you that trick sometime, how you can do multiple edits. It's depends on the shortcut on my keyboard. But basically, if you put this in front, this dot in front of all the references of noise there, and hopefully if I reload that page, oh yeah, look at that, it's a lot faster now. But that one isn't, it's well, actually that's not bad because it does multiply out, doesn't it? Whoa. Oh, okay, yeah, this is interesting. I think my shots go too far though. I think it's too, oh, spoke too soon. But I think the shots are going too far off the screen and out beyond, and it's too effective. So I am going to just rein them in a touch. Let's see, what was it lifespan? Let's bring that down to 100, no, say 120. Okay, so we'll set that to 120, and let's just see how far my shots go now. Ooh. Yeah, do you know what? I think I'm happy with that. Wow, this is whoa. Actually, this is all right. Whoa. Okay, certainly giving me a do you know what? Yeah, let's crash the game. Yeah, this is going to be interesting. I like this. Okay, I'm going to call it quits there on this for today, and I think I'm happy to call it quits for the single player. I might come back to it at some future time just to do some enhancements perhaps, but you know, as an exercise, maybe you might want to learn some features, see what you can do with this yourself. But I'm happy with this now. The core playability is there. I haven't done a score sheet or anything, but again, what I might do is when we do the multiplayer, when we come to plan out some of the features like the scorecard and stuff like that, we could come back to this then and try it here and develop it here in this environment, and then we just transfer it across. That could be an idea. That said, I'm happy with this now. Have a tinker with the code yourself. I might set up a Git repo, and might do a video on how to download a Git repo so you can get the code yourself without having to type it out manually. But definitely next time, with regards to the tutorial, we're going to start the multiplayer. I am so excited about starting the multiplayer version of this. So good. Thank you very much for watching this video. If you enjoyed this video, please like. If you've enjoyed the series so far, please subscribe. Tell people who you think might be interested in it. Because we're going to be starting the massively multiplayer version of this, which means it's going to look similar to this, but imagine it with many other different players playing live. There's whole new things we're going to learn about how the server side things works, how to do more interactions on the screen. We're going to have to properly keep account of scores, and we might change how the asteroids work. I've got so many ideas we can rub with this. So yeah, please stay in touch, and hopefully we'll see you on the next video and the next series, which is the Asteroids massively multiplayer online. Thank you for watching.